Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Anecia Hoffield, a regional engineer in our southeastern region, and we're going to be talking about how to prolong bearing life. Hey Anecia, how are you doing today?
Good. How's it going, Collie?
Doing well. Thank you for coming on. Today we're going to talk a little bit about bearings, how to prolong their life, and maybe a few factors that will shorten their life. So what are a few of those?
Yeah. So we'll talk about some main ones, which is overhung load, preload on the bearings, and axial loading.
Okay, so let's just go ahead and start with overhung load. What is it, and what are some of the factors that lead into it, or how we can avoid it?
So overhung load is when there's a force 90 degrees on the bearing. And a lot of times we'll see that if there's an external load on the shaft. And that happens a lot if there's an external ratio if you think about sprockets and gearing, or maybe even belt drives.
Okay. And so when you're having this load pressing down on the shaft, what are some of the things that can happen that make the failure occur, or how do we keep it from occurring? Because I mean, those applications are everywhere, and we can't just avoid the application.
Yeah. So what causes it to fail is that force presses down on the bearing and it pushes the balls to one side. And as that shaft continues on rotating along, the balls are seeing more pressure on that one side, but then releasing the pressure on the other side. So it's just uneven pressure going around. And eventually those balls begin to wear
Right.
and the races of the bearings begin to wear and fail. So some ways we can avoid that in the application itself, it really depends on your overhung load and if you're using a pulley, it's going to depend on the diameter of the pulley itself.
Okay.
Also, the customer, they can add a pillow block bearing
Right.
on our shaft or on their shaft, and that's just going to help with alignment. And that pillow block bearing is going to see the force instead of our gearbox.
So it's going to alleviate some of the load, and then that way the balls in the ball bearing are not going to be compressed, causing that premature failure.
Exactly. Another way, so if that's not an option for the application, or if you can't change any of the diameters of the pulleys, we can look into the gearbox. And some of those is reinforced bearings.
Okay.
So basically that's just two bearings instead of just one bearing.
And they'll be sharing the load, and that helps alleviate the problem.
Exactly. So they'll share the load, and so you'll prospectively get double the bearing life.
Right.
Now, some of the gearboxes, that's not a plausible issue because it doesn't have any room for double the reinforced bearings.
Okay.
So then we move into safety factor. Now, safety factor, if you have a really low safety factor and a really increased overhung load, we really see those bearing failures a lot.
Gotcha.
They're going to fail within a year or so, depending on the load and depending on the safety factor you're seeing.
Okay.
So even though like our general rule is at least above a 1, if you have really high overhung load, you're going to see a failure if it's like 1.5.
Gotcha.
Now, so we can increase the service factor, go up in gearbox size that way, and that's going to, a bigger bearing is going to help alleviate and be able to handle the stress of that bearing.
Makes sense.
Yeah. Now, it does also get into the point of you have higher torque and higher speed. So maybe you don't have overhung load in your application. Maybe you just have a really high torque application, but it's going super fast.
Right.
And that's where we also see some wear and tear on the bearings and premature failures. And that goes into like, if your service factor is from like 1.0 to 1.6, we see this a lot.
Okay.
Now, what happens is those bearings are just moving so fast, but that load stays the same. And so those bearings are just kind of running out of life faster.
Right.
And especially like if you heard about super driving, we have to check the bearing life if we're supercharging or super driving a gearbox then.
Makes sense.
Because it's going to be a smaller gearbox, but now instead of running at 1800 RPMs with whatever torque, it's running at 3600 RPM.
And that increased speed most definitely needs a little more safety factor to be able to handle that.
Yep.
So what I'm hearing is more safety factor equals more bearing life and is always good.
No.
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 Okay.
So then we get into some of the gearboxes need that load.
So we're going to be talking about preload.
Yep.
Okay, here we go.
So that goes into preloading now. And preloading, what happens when we see preloading is that bearing is usually tapered rolling bearings. They don't have enough force to roll.
Okay.
So what happens is they start sliding. And the inner ring still goes around no matter what. And if there's not enough force to make those rollers turn, it's going to slide along those tracks. And they're going to start getting super hot and degrading. It's going to degrade the cage, the inner rings, and the rollers. So that's why it's really important to just not go up to a 10 service factor for other reasons too, but mainly because of those bearings as well.
Because it sounds like roller bearings are supposed to roll, and once we start sliding and creating heat, heat is usually a bad thing within gearboxes, so we need to avoid that.
Exactly.
Well, awesome. And I think you mentioned axial loading as the last of the three major causes of bearing failure. So what is axial loading instead of overhung loading?
So axial loading is going to be within the shaft, like in the direction of the shaft.
Okay.
And most of the times we see it is during installation. Whenever that gearbox is just not lined up properly and a little bit off, what happens is the gears or even the application puts pressure into the bearing. And so the balls are shifted to one side versus like if we were doing overhung load, it was 90 degrees. So they were all shifted like down.
Right.
But now they're all shifted to one side of the bearing and rolling like that. And it just causes uneven wear and it's going to see a failure.
So it sounds like those are the three major causes. And what I've gathered is if you have an application with some kind of odd loading or higher speeds or just even high torque, definitely work with your regional support or even some engineering to make sure that application is sized properly so we can just avoid these altogether.
Exactly. And we have a software called WESI Lab in our engineering department that will run your unit, run the load that it's supposed to be seeing and how fast you want it. And we can show you the estimated bearing lives.
Well, that is a great tool to have, especially in the planning phases of some gearbox. So it sounds like we've touched on a lot about bearings and what could cause them to prematurely fail. Is there anything else you'd like to say, or is that about it?
Nope, that's about it.
Well, thank you so much for your time today, and I really appreciate it.
All right, thank you.